What's up, math scholars? Mrs. Harp here. We're going to do lesson 9, day 1, but I'm going to record the warm-up because the warm-up will lead into the lesson. Chapter 9 is all about triangles, solving triangles, right triangles, non-right triangles, all that stuff. So, let's look at this triangle. What type of triangle is it?
Right.
A right triangle, because we see this right angle here. Anytime you have a right triangle, you can definitely use sine, cosine, and tangent, just like you learned it in geometry class last year. For one ticket, can you give me the phrase you learned in geometry class that helps you remember sine, cosine, and tangent? I only call on people that are sitting in the seat assigned by the teacher, so get there quickly. Kylie. Yeah. So, Philip. You don't remember that, jot it down. Okay. Here's where we're at. It was on pause. So we're doing sine, cosine, and tangent today. Sine is opposite over hypotenuse. Cosine's adjacent over hypotenuse. And tangent is opposite over adjacent. But before you do that, before you sub your fractions, you have to know how to label your triangle. So can everybody in here point to where the hypotenuse is located? Just point to it. Are y'all pointing over here? Because Ethan, you look like you're pointing left. So the hypotenuse lives across from the right angle. The hypotenuse lives across from the right angle. It's also always the longest side. Now, depending on what angle you're working with will depend on what side is your opposite and your adjacent and all that. They did mention that we're working with angle A, so I'm going to put a little theta right there. It's a Greek letter called theta. We're going to be using it a lot. But if I'm living down here at angle A, and this is my theta, is my 12 an opposite side or an adjacent side? Opposite, because it's all the way across the triangle. Now, can your hypotenuse also be labeled as an opposite side? No. Your hypotenuse is your hypotenuse is your hypotenuse. It can never be an opposite or an adjacent. It's the legs that are your opposites and your adjacents. So that makes my 5 my adjacent, because it's literally touching the angle. And we're ready to answer the question. So sine of angle A would be the opposite side over the hypotenuse side. The opposite side measures 12 kilometers, and the hypotenuse measures 13 kilometers. So what would we answer? C. Very good. So any questions on that? All right, we're ready to go with our actual lesson. So who's excited about right triangles today? Yeah! Alrighty, 9-1, day 1. It's so easy. It will be done fast, and you guys will have homework time, okay? So we kind of already discussed labeling, but can you just point for me where the hypotenuse would live? Very good. I'll just call it H. If this would be my theta, can you point to where the adjacent side would be? Very good. The one on the left. And can you point to where the opposite side would be? Very good. The one on the bottom. Does everybody agree? Any questions? Because I'm going to erase that and we're going to retry it with a different theta. All right. I got a different theta now. It lives down here. Can you all point to where the hypotenuse would live? It doesn't change, right? The hypotenuse is always the hypotenuse, regardless of where your angle's living at. Point to where the adjacent side would live. That'd be the bottom, because it's the side that's right beside. Adjacent means right beside. So it's the side that literally touches the angle. And then your opposite side is across the way, so up here. All right, so who would like to earn a ticket and a cookie today? Ticket and a cookie for volunteering for this one. I was waiting for Marty to raise her hand because she's really hungry. Do you want a ticket and a cookie?
No.
Not so much. Not that bad. Let's go with Brittany. Your job is to, this triangle only, label hypotenuse, opposite, and adjacent. You can just do H and O and A, okay?
This one here to your H. That's really and then it's your adjacent, and then that's your opposite.
Y'all agree? Sorry, my board isn't right. My board is not right well close to the edge. Very good. Who would like to volunteer next? Let's go with Jessie. Huh? Do you guys think she's right? Ticket cookie, unless you don't want to. And then we get our third one. Let's go with Nick Meister. I just lined it up before class. Do you guys think he's right? Pick a cookie. Okay.
I have a cookie.
He's going to share with a friend of his choice. Okay. Moving along. All right. So question, let's look at this first triangle very closely. Do you guys think we would use sine, cosine, or tangent to solve for it? Solve for x. Exactly. We would not use sine, cosine, or tangent because we're not working with the angles at all. We'd use the Pythagorean theorem. I'm actually going to give Spencer a ticket for figuring that out and even using the words Pythagorean theorem. So here's how Pythagorean theorem works. It's a squared plus b squared equals c squared. It should all be reviewed for you. Where a and b are your legs, so your 5 and 7 are a and b values, and your c value is your hypotenuse, so it has to be the x in this case. Okay, we will need your calculators for some of the problems we'll be doing today. What is 5 squared plus 7 squared? 74. And then that equals x squared, so how do I finish it off? Square root it. And if it doesn't square root perfectly today, you can just leave it as radical 74. If you want to be super scholar, you could break guys out of jail. If anybody would break out of jail? Would it? Would somebody break out of jail?
No, no, the 2 and 30 now.
2 and 37.
So yeah, nobody would break out of jail if it would break down to 2 and 37, so we'll just leave it. All right, heading over to our other triangle. How would I use the Pythagorean theorem to help me solve for x? 1 second, if you can set it up for me. Let's go with Spencer. You can just tell me.
Okay. 3 squared plus x squared equals 12 squared.
Perfect. I wanted to make sure he knew that 12 had to be his c value, because that's the hypotenuse. 3 squared is 9. And 12 squared is 144. How do you move the 9 over? Good! So I had somebody tell me divide last period. Subtract is correct. Clearly. So that gives us 135, and then square root. I wonder if the 135 would break down. Let's try it. 5 and 27. So yeah, actually. Yeah, let's just be scholars, because you guys are such a scholarly class. Let's be scholars and kind of break this down and simplifying it a little bit. And refresh that skill, honestly. So 135 is 27 times 5. 27 is 9 times 3. And 9 is 3 times 3. So if you remember how that works, you kind of circle your pairs. So I would circle my pair of 3s. This 3 that is circled would get out of jail. The other 3 with him would get canceled out. And then inside of jail, I'd still have a 3, and I'd still have a 5. So I kind of leave it like that. That was chapter 2 at its finest, just breaking radicals down and simplifying stuff. Back in the good old days. September and October. I'd much rather be in April than September and October because we're a lot closer to summer. Kylie's countdown currently is 37 days until June 1st. School days. Yeah. All right, ready? Oh, keep it for a second? Yeah. Let me pull up my pause button and pause it for you, okay? Totally up to you if you want to jot this down. If you remember it from last year, you can just not jot it down. It's up to you. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. And the key here is you only want to do this stuff when you have a right triangle. If you have a non-right triangle, you can't do this stuff. You have to use other formulas that we'll learn about later in the chapter, like the law of cosines and the law of sines. Yeah, so I'll hit pause if you want to jot it down, you can. It's only Wednesday. All right. So these are new, although my last class told me they did them in geometry last year. So basically cosecant, I know it starts with the C, so you would think it would be opposite. Cosine is actually the opposite of sine. So once you figure out sine, all you have to do is flip your answer. Secant is the opposite of cosine, so once you get cosine, you just have to flip your answer. And then cotangent is the opposite of tangent. When you get it, you just flip your answer. So I did put those 3 up because I thought they were new for you. But then people told me, we saw it last year. Piece of cake.
What are the abbreviations?
Hello, you're back, math scholars. So we've got a triangle up here. We are missing what the hypotenuse is. So we probably want to solve for hypotenuse. Let's start ourselves off doing that. How would we solve for a hypotenuse, students? Lexi? Yeah, Lexi went ahead and set up the Pythagorean theorem for us. 5 squared is 25, 144. What's 25 plus 144? 169, and then go ahead and square root that. So it's one of those perfect ratios, that 5, 12, 13 triangles. We learned about all those last year. Like, you know, the 3, 4, 5 triangles, 5, 12, 13 triangles. All right, we're ready to rock. Our hypotenuse is labeled, but let's label our opposite and our adjacent. Is 5 going to be opposite or adjacent to theta? Good. And is 12 going to be, that makes 12 opposite. I don't even know why I was asking that as a question. So we're ready to rock and roll. Sine theta would be opposite over hypotenuse. So what would the fraction be I would write? 12 over 13. And you don't have to actually type in 12 divided by 13. You're just moving along. Today is all about setting things up and not actually calculating things. Cosine, what would that fraction be? Adjacent over hypotenuse. 5 over 13. Tangent, opposite over adjacent. 12 over 5. Now, since this is our first time doing cosecant, secant, cotangent, I'll give you a trick. Cosecant is just reverse of sine, so you just flip your sine answer upside down, 13 over 12. Cosine is just reverse of secant, so you flip your answer upside down, 13 over 5. And tangent is just the reverse of cotangent, the reciprocal of, I should use the word reciprocal. Reciprocal, 5 over 12. Sweet. You can do the first 3, you can definitely do the last 3. Question? All right, this time I'm going to ask you to draw your own right triangle. So draw a right triangle on your paper, however you picture a right triangle looking. Go ahead and put a theta into your right triangle, wherever you feel like putting your theta. Doesn't matter, doesn't need to match me. Now what I want you to do is put the information given into your triangle. So here's what I mean by that. Sine of theta is 4 over 7. But if you remember, sine is opposite over hypotenuse. So you should basically make a 7 your hypotenuse in your triangle. This is where my hypotenuse is. And you should make the 4 your opposite side in your triangle. So wherever you labeled theta, you should travel across the triangle, and that's where your 4 should go. Does that make sense? Okay, before we write out what tangent theta is, because that's what our goal on the math problem is, we need to find the other side of our triangle. So we have 4, which is a leg. We have 7, which is a hypotenuse. We need to find that other leg. So let's use our Pythagorean theorem. 4 squared plus x squared is 7 squared. So I got 16 plus x squared equals 49. Let's subtract over your 16. What is 49 minus 16? Yeah, so that's going to be just the radical 33 for the final answer. You can't really break down a 33 out of jail, so I would leave it.
No.
All right, so at this point, we want to do tangent theta. Opposite over adjacent. The opposite side's 4. The adjacent side's radical 33. And I'm allowing you to leave it like that. True mathematicians would rationalize that denominator. They would use some multiplication to get that radical out of the denominator. But I'm okay with you just leaving it. We accomplish our goal of working with a triangle. Okay? Okay, this is going to be your graduation problem. I had one student look at that square root 160 and go, I think that would break down. I said, yeah, why don't we break that down together? Yeah. I accidentally didn't erase my work from 3rd period, so y'all can see what I did. 160 was 16 and 10. 16 was 4 and 4, so I broke a 4 out of jail. So basically, to be more scholarly, I would write this 4 radical 10 before I would go doing my my ratios. Okay. I'll do the first one with you just so we can talk about the whole simplification thing. All of these would have thetas. For some reason, I didn't type the thetas in. You have to take sine, cosine, and tangent of a theta. And you can see where theta is labeled is in the upper corner of our triangle. What would 12 be? Opposite, adjacent, or hypotenuse? Okay, great. What would 4 be? And then what would this side be? Alright, so I'll do the first one with you. You can do the other 5 to see if you can graduate. Sine theta, opposite over hypotenuse. So it would be 4 over 4 radical 10. The 4s would just cancel out, and I would want you to probably leave it like this for your final answer. 1 over radical 10. Okay. Go ahead and try the other 5 all by yourself. If you're watching at home, you can pause the video and try the other 5 by yourself. Hello, viewers. We are going to go ahead and give you some answers. We did the sine together. So for cosine, I did adjacent over hypotenuse, 12 over 4 rad 10. I did reduce the 12 over 4 to a 3. Tangent was opposite over adjacent, 4 over 12. That reduced down to 1/3. And then to get the final answer, so I just flipped the top 3 answers. So flipping this would be radical 10 over 1. I didn't write the over 1. Flipping the second one, you would get this. Flipping the third one, you just get a 3. So raise your hand if you graduated. Very scholarly. All right, I'll go ahead and show you the homework then. It's 4 to 16 evens. Thanks for watching the video.